Okay, guys, we are going to try and do some of these Desmos problems on this video so that you guys have something to work with to better prepare you for Thursday's midterm. So, we've done some of this in class, but let's take a look at the first calculator problem where you need a calculator or Desmos. It says the height of an object at time t is greater than or equal to 1 is given by this equation. What is the velocity of the object at time t equals 3? Okay, I'm going to go over here to Desmos. Wish I was doing this with a keyboard, but I'm not, so you'll have to be a little bit patient as I type in on my iPad. I'm going to use the letters in the problem. H of t equals t squared minus 16, let's try that again, 16 divided by t plus 15. All right, this is vital. You have to tell Desmos what you want it to look at. You can pinch and zoom this way as well on your computer, and I'll show you more about how to do that in class. I mentioned it in class. But what we want to know is the velocity of this object at the time t equals 3. Okay, well, we have an equation for height. Height is a form of position. The derivative of position is velocity. So now I just have to type h, if I can find it, h prime parentheses 3, and there is Desmos giving me the answer. Boom. That easy, and you'll be able to type it in much more easily on a keyboard than I can on this iPad. That's number 77. The next one, where Desmos is actually useful, is on number 80. Now, this is a tricky type of question, and the way you have to think of it is, okay, here is a function that's described as g prime. That means we're looking at a derivative. And the information they give you is g2, g of 2 is equal to negative 7. G would be the antiderivative of what you were just looking for. And they're asking for the value of g5. All right, I'm going to approach this a little bit backwards here. Think of it this way. You're walking along the x-axis, and as you go, you're collecting area. Well, why do I say that? Because if you antiderive this, that was not supposed to leave a mark. Okay, here we go. If you antiderive this, you're going to get the area under a curve that they're calling g prime. So the amount of area you pick up would be the integral from 2 to 5 of this g prime function. But if you're picking something up, it stands to reason that maybe you didn't start from 0. Maybe you had some, maybe you didn't. In this case, you started with a value of negative 7 when g was 2, and think of this integral as saying, after you start at negative 7, how much more area will you get as you walk down the x-axis from 2 to 5? Now, this integral that or this function that I've highlighted in yellow does not look like a lot of fun to antiderive by hand. So I'm going over here to Desmos, and I'm going to ask Desmos to tell me, go to APC and type int, that gets me an integral. You can also find it under functions. This functions button will also, if you scroll down, eventually you get to calculus and you see there's an integral sign there. But in that integral sign, I'm going to start at 2. I'm going to go to 5. And now I'm going to type in, here's a square root button. And under the square root, I'm going to put x raised to the third plus x I have to go out from under the square root button. That's what I did with that, with an arrow, one of the arrow keys. And I have to put dx. Okay, now that looks like one of the answers. Problem is that's the area. Well, see, we got 20.899 over here, one of the choices, 20.899. Don't want to circle that one though, because from 2 to 5, we picked up that much area, but we started, I'm going to go back over to Desmos for some help here. We started back here at -7, and then we added that area. Let's get rid of that extra little thing I put in there. And the actual answer we want is now 13.899. The problem's a little tricky. Come by and see me if you have more questions on it. Now the next one, where it looks like we might need Desmos, is 83. Let f be the function defined above where k is a positive constant. For what value of any is f continuous? All right, well, this will be continuous if when x is equal to 3, the y value is the same for each of these pieces of this piecewise function. In other words, if I put 3 in for x into the first function, it should be the same as if I put 3 in for x into the second function. This does not look fun to solve by hand. When I should actually put the 3 in there. This does not look fun to solve by hand, nor do you have to. I'm going to go over to Desmos, and I'm going to delete these things to keep them from distracting me. And you know what? I'm going to see if Desmos will even let me use the same letter here. I'm going to put 2 functions into Desmos. F of k equal to k cubed plus 3. Oh, look, Desmos is graphing that. Why am I making this a function? I'll show you in a sec. Then I'm going to put g of k is equal to, put in the fraction bar first, put in the 16, go down there to the bottom, 16 over k cubed minus 3, and I'm going to see where, if anywhere, these functions intersect. Looks like they intersect at 2 places. And Desmos gives me the option for certain points to hit a little icon next to it and make the point appear. Now, Desmos is telling me that I have 2 intersection points. The problem says k has to be a positive constant, and so I can eliminate one of them. All I really care about is the second one, but I'm getting this occurs at a k value of the wrong number, and I'm suddenly realizing I typed in a 3 where I meant to type in a 2. Let's try this again. Get rid of these distracting points. 2.081. Okay, that's more like it. Answer's A. Really helps to type things into Desmos correctly. When it works, it's great. So what Desmos told me is where these 2 functions intersect, which is the same thing as solving this equation. Okay, let's see where else Desmos can be helpful. Probably not that one. All right, let's look at 85. For 85, the function f is an antiderivative of the function g, where g is defined by something kind of monstrous. Which of the following is the x-coordinate of the local maximum for the graph of y equals f of x? Okay, can't stress this enough here. They're not asking for a maximum on g of x. They're asking for a maximum on f of x. Here I'm going to show you what I think is probably the easiest way to solve this one. All right, I'm going to put in g of x. I could just call it y, but sometimes the function notation is helpful. I'm going to more carefully type this one in. X squared plus x plus 4. Go over to ABC, type COS. Desmos knows what that means. X. Expand it so I can see it a little bit. Okay. Now it looks like, based on the choices, we really only care about this graph between, I don't know, -4 and +4. I'm going to adjust my axes so that I see it a little bit better. Now, remember the question is about f of x, which is the antiderivative of this. We're looking at g of x. We're looking at the derivative of the function they're asking about. Well, I'm going to indicate some x-intercepts here. I only see 2 of these x-intercepts. One of them at -3.961, the other at +3.14005. Both of them are basically choices here. So I'll show you how to treat this, and so you can look at it later. I'm going to take a picture. I'm just going to grab a limited part of the Desmos piece, copy and delete because I don't need it later, paste it into there. Now let's take another look at notability. Okay, what I've done here is another type of sign analysis. I am looking at g of x, which is the same as f prime of x. I'm looking at a first derivative graph where the first derivative goes -0, +0, then negative. Okay, that plus sign looks too much like a T. In other words, if I graph it on a number line like you might be more used to seeing, just put these 2 points on. That's where it's 0. The first derivative goes negative, positive, negative. That means the original graph must be decreasing because that's what graphs do when the first derivative is negative. Then it's increasing. Then it's decreasing again. Now, if a graph is decreasing and then it has a horizontal tangent line, which is what a 0 in the first derivative tells us, well, a graph that decreases, goes horizontal, and then increases does so at a minimum. A graph that increases, goes horizontal, then decreases does so at a maximum. We were asked to find the x-coordinate of a local maximum on the graph of f of x, which is the antiderivative. The maximum occurs there. The answer is D. Did I have to draw the number line? No. Could have gotten that from the graph. If I'm looking at a graph of a derivative, and the graph of the derivative goes positive, then 0, then negative, I automatically have a maximum on the original graph that we can't see. All right, that's number 85. Let's see where else Desmos can help us, not when they give us pictures. Okay, good. This one, 87. At time t between 0 and 2 seconds, the velocity of a particle moving along the x-axis is given by that function. Let t equals b the time at which the particle changes direction from moving left to moving right. What is the total distance traveled by that particle during the time interval, 0 to t to b? Okay, get rid of this distracting stuff from Desmos. I am just going to put v of t in here. Yes, I could use f of x and x, but I like being able to use different letters. So I'm going to t sine parentheses t cubed. Of course, I didn't finish writing sine, so that's going to be a problem in a second, but let's go back over to here. Type in that letter n. That's a fun-looking graph. Now, if this is distracting, how it's behaving, remember, they just said they only wanted it from 0 to 2. I can put in my little brackets and go 0 less than t less than 2. I don't think they said equal to. Nope, they didn't. And all of a sudden, I have a much more reasonable graph to look at. Now, let's reread the problem because these can get confusing. All right. Let t equals b be the time at which the particle changes direction from moving left to moving right. Okay. More sign analysis. When this velocity graph is above the x-axis, when it's positive, it is moving to the right. When this graph goes negative, it's moving to the left. So the first time it goes from moving left to moving right would be when it switches from negative to positive, which looks to me like it happens here at this 1.84527. I'm thinking that's the point that the problem is calling. I can get my keyboard back here. Oh, and look, Desmos will not let me label this point B, but you'll be able to do that on a bigger screen. What is the total distance traveled by the particle during that interval? Okay, so now what we want is an integral again. So I'm going to type int. I'm going to go from, let's see if Desmos will quickly, nope, it won't let me label it that way. All right, I'm going to go from 0 up to 1.84527. And now I need an integral to go from velocity to distance. The thing is, the particle's moving to the right and while it's positive, to the left while it's negative. If I just take the integral of v of t, I'm going to get displacement. I need to make that negative area positive. I could do that by separating this into two separate integrals, grabbing that 0 point, but there's a simpler trick. I am going to go over to ABC. I'm going to have to go looking through the functions because I'm not on my computer for a minute. I need to find absolute value. Now it's easy to type that bar in that's on your keyboard when you have your computer, but I am suddenly realizing that I have not done this before this way. Let's see if there's a keyboard shortcut. Sometimes that happens. Okay, ABS. Hopefully that means absolute value of V of T. Now remember, your end variable has got to match your variable that it's a function of. So if it's v of t, you have to have a dt at the end. Okay, that seems to be a choice, and it seems like a reasonable one. So hopefully that ABS meant absolute value. One way we can check is by taking it away. Go to settings, duplicate this, take away the absolute value part, and we do get a much smaller amount, which makes sense. If this positive area was having that negative area subtracted from it, we'd accept something smaller. So I'm pretty sure that's what ABS means. Man, I've been spoiled by my computer keyboard being able to type in an absolute value. All right, let's see if there's anywhere else that our calculator can help, or if Desmos can help. 88, let f be the function defined by, for how many values of x in the open interval is the instantaneous rate of change equal to the average rate of change on that closed interval from 0 to 1.565? All right, Desmos is absolutely going to save us, and I will show you how. This one will be a little easier to type. Going to stick with x's, going to try to stick with x's. Okay, so let's see. This will take me a moment, especially if I keep missing the division sign. 1/4 x to the 4th minus 2/3 x cubed plus 1/2 x squared minus 1/2 x. Taking a moment to double check that I have graphed that mostly correctly. All right, I'm going to go back to these brackets because for purposes of not being distracted, we only care about this thing from 0. Okay, the brackets on the closed interval make me think I want to use less than or equal to as opposed to less than, and I'm going to use 1.565. All right. This is not my favorite graph to look at for this, but what this is saying is, I'll give myself a little more room here. Okay, I'm trying to find a window. This will be most apparent, but what we need to do is figure out how many times there is a parallel tangent line to the secant line connecting these 2 points. If I try and do it, I'm going to try and do this by hand and notability first, and we will see how that goes. Okay, first I just want a picture of everything that's not distracting. Take that picture back over to notability. Let's take a look at what we have. Okay, if I carefully connect the beginning point and the ending point with a straight line, it looks like the tangent lines, there might be, so there's a horizontal tangent line in there somewhere, and again in there somewhere. These look like places where I can draw, that one's really close in, a horizontal tangent line. Actually, that one, when I zoom in, looks closer to looks like it's closer to up here. Okay, so it looks to me like this could happen 3 times. That first one being slightly less clear. So what they're saying is there are 3 times that the mean value theorem is satisfied between those 2 values. Okay, so that's number 88. 89 and 9 is not a Desmos problem, and neither is 90. Okay, I realize that was a little sloppy in places, but those are some of the ways Desmos can help you. I hope this video helped you guys out before Thursday. All right, see you then. Come by if you get a minute around your other midterms to ask me questions.